Welcome! In this series of short videos, we will look at topics common to both the PowerBasic console and Windows compilers. Today we will revisit the searching and comparing of arrays using indexes. Today we're going to revisit some of the routines we created for doing search and comparison of arrays. The folder we see on screen now is where our search and compare program is going to sit. I've created a subfolder underneath that called Data. This subfolder contains a Generate Data application. Since we want to compare two sets of data in this video, we're going to generate some random data with people's names, addresses, telephone numbers, and email addresses. What we're looking to do is to generate two data files, both of them comma-separated variable files. The scenario this is going to simulate is where you have two sets of data, a large dataset and a smaller dataset which is a subset of the larger dataset. And we're going to add 20 new records that do not exist in the large dataset to the small one. And the task for the application is to check each record in the small dataset to see if it exists in the large dataset, and report on all records which are not in the large dataset. Since PowerBasic is so fast, I'm going to generate a lot of data. Our large dataset is going to contain 100,000 records, and the smaller dataset will contain about 10% of that. I'm not going to go through the Generate Data application in detail, as we've used something similar to this several times before in previous videos. However, its task is to produce two files, one called Big Test Data File and one called Small Test Data File. The maximum number of records we're going to be generating in the large file is 100,000. In order to generate these files, we're calling a function called GenerateFiles. This will produce a dataset consisting of a number of columns, ranging from first name and surname all the way down to the age of the client. We will then wipe any evidence of the two files. Within this folder, I have a number of seed files. These contain sample first names, both male and female, surnames, streets, and cities. The cities file has two columns, one for the name of the city and one for the region. And having populated these arrays with this seed data, we're going to call a function called getRandomData, which will return some random data, which will be one record. So we'll be calling this function 100,000 times. And of those 100,000 records, approximately 10% of them will be written out to the small file. And once that exercise has been completed, we're going to generate 20 more records. These records will not be in the large file, but will be at the tail end of the small file. So let's compile this application and attempt to run and generate these two random files. There is our Generate Data executable. If we double click on that now, it will begin to generate 100,000 records. This random information is useful for our comparisons. And PowerBasic will generate 100,000 records very quickly indeed. This video is not speeded up, it's going in real time. And there we have 100,000 records. So we have a small test data file containing about 10,000 records, and we have a large data file containing 100,000 records. As you can see, we have names, genders, date of births, addresses, a city, a region, a postcode, a telephone number, and an email address. We're going to be treating the email address as the unique identifier of each individual record. So that email address is the thing we'll be searching out between the two files. Now that we've generated the data, how can we make this comparison to find out what is in the small file but is not in the large file? To do this, we're not going to write a great deal of code. We're going to bring in one of the libraries we've written previously, the PBArray functions library. We're including this at the beginning of our application. Now this library needs three constants. Index search, which is either going to be true or false, and then if we are using the index search option, we need to specify the start and end of the index for our unique character. I'll explain more of this later. So we'll need to tell our application the names and locations of the large data file and the small data file. So I'm putting those in string constants. They're in the subfolder called data and followed by the file name. We're going to be loading each of those files into a large data array. So we will prepare two global data arrays at the beginning of our application. And we're going to create a new function, look for missing records. This is a function that's going to be doing the comparison and the reporting of the difference. So within this function, we need to do two things first of all. We need to load the data that's in the large and the small data files into those arrays. So we can perform that function quite easily by using another library, the PB File Handling Routines library. It has in it a function which reads a file into an array. All we need give it is the path and location to the file and the array into which the data is going to be put. If this successfully loads the data from the file, it will return a true. If for any reason it cannot load the file, it will return a false. And in that case, we can put a message out to a log to say we've been unable to load the data. So in order to determine how long this function takes to run, we're going to capture the timer at the beginning of the function and report on it at the end. So we will declare a quad variable called duration, and we will populate that using the inbuilt timer function. And now we want to compare these two arrays which we've loaded up from the files. In our array functions library, there's a pre-built function especially designed for this kind of activity. It's called indexArrayCompare. This function takes a number of parameters. I'm going to declare some local variables so we can actually make these more readable. Since this is a CSV file, we know that the delimiter between fields is a comma. So the first parameter we're going to be populating is the delimiter parameter, and we're setting that to be a comma. In our file, we need to know the name of the column which we consider to be the unique identifier of our record. In this case, the unique identifier is going to be in the email column. So our unique field name is email. We're looking for data which exists in one array but not in the second array. So our comparison type will be missing. And also this function only supports single dimensional arrays at the moment. So the number of dimensions in our array is 1. Having populated these variables, we can now call our function within the library. And here are our parameters. The first parameter is the small data array. This contains the contents of the small file, around 10,000 records. The second parameter is the big data array. This contains the 100,000 records. The third parameter is the array into which we want to put the result of our comparison. In this case, this will be the number of records that exist within the small data array, but do not exist within the big data array. So this will report on the entries missing from big data. Third parameter is our delimiter. In this case, it's a CSV file, so that will be a comma. The unique field name we're looking for is the email column. The comparison type is missing. The error is a variable which will be passed back should an error occur within the comparison. And the number of dimensions, as I said, is 1. And should any error occur, we can throw that one out to a log. So now that it's done the comparison and saved the result into the str report data array, we'll now want to save that back to disk so we can have a look at it. So we're going to use yet another function in our library, the ArraySave1D function. This saves a one-dimensional array to disk. This takes 4 parameters. It needs to know where to save the file and the name of the file, which is the first parameter. It needs the name of the array to save, which is our report data array, and it needs 2 additional parameters. This function allows you to change the delimiter from one thing to another at the point of saving. In this case, the existing delimiter and the new delimiter are still going to be commas. and once we've saved the file to disk, we can then output to our log how long the function actually ran for. We can do that quite easily by subtracting the duration value from the timer as it stands now. This will give us a number of seconds between the beginning and the end of the function, and we can push that out to the log. So let's try a compile of our code. And it compiles quite cleanly. So here we are back in our folder with our search and compare 2.exe. If we double click on that now, it will begin the comparison. It's now loaded big and small data files, and it's running through around 10,000 records in about 8 seconds. So it's now completed very quickly. So if we now have a look in the data folder, we'll see we now have an output.csv file. And the output.csv file has 20 records in it. If we look inside the small test data file, and we look down to the very bottom of that file, we will see the bottom 20 records in the small data file are the ones we added at the end that did not exist in the big file. And if we look at the 20 records returned on the comparison, it has found all 20 records. And it did all this in only 8 seconds. For this comparison, we were using an index search. So let's turn off the index search to do a normal search. We can do that quite easily by changing the index search constant to false. If we try compiling our application now, and then we'll try rerunning it. And there is our search and compare. If we run that now, the big and small data load just as quickly. However, the searching is going considerably slower than it did before. The reason for this is quite straightforward. For each record in the small file, which is around 10,000 records, it has to search to see if it can find a match in the large file. So it may have to search through many records before it actually finds the match. In fact, for some of the records in the small file, it may have to search through almost 100,000 records in the large file. And certainly for the missing ones, it would have to do that at least 20 times. This explains why it's so slow. So why does the index search speed it up so much? The idea behind the index search is that what we're doing on the large file is we are pre-sorting the large file into a sorting order based on the email column. And having sorted it in that order, all the email addresses beginning with A appear at the top, followed by all the email addresses beginning with the letter B. And as well as sorting this array alphabetically, we also prepare a series of indexes. This says where the letter A begins, what row it's on, and what row it actually finishes. This allows you to know where to start looking. So if the email address you're searching for starts with K, then it would only start at the beginning of the letter K emails. Therefore, it cuts down the amount of records you have to search through, giving you a much faster way of actually processing this task. So doing it without the index search took 126 seconds. Doing it with the index, it ran in 8 seconds. So you can see the advantage of using an index search. It does make searching large datasets and arrays very much faster. Please feel free to have a look at the index array compare function in the array functions library. Hopefully you'll find this code useful in your applications, but that's it for today. Thank you for watching.